This is SpaceTime, Series 27, Episode 136, for broadcast on Remembrance Day, the 11th of November, 2024. Coming up on SpaceTime, discovering the origins of Magnetars, NASA's Voyager 1 spacecraft about to reach 1 light day away from Earth, and Australia acts as a vital military satellite defence system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that highly magnetic neutron stars known as magnetars are actually born out of stellar mergers rather than single-star supernova events. The findings, reported in the journal Nature, follows new research into the origins of fast radio bursts. Fast radio bursts, or FRBs, are sudden high-energy flashes at very specific wavelengths, lasting just nanoseconds and usually originating at cosmic distances. But in that time, they can release more energy than 500 million suns. The first fast radio burst was discovered back in 2007. That was in data from the Parkes Radio Telescope in New South Wales. Most are singular events, occurring just once at a specific location and then never again. And that suggests they're caused by some sort of cataclysmic event, such as a supernova, the destructive explosion of a star. But astronomers are now detecting more and more fast radio bursts that have repeated from the same location, and that suggests a different cause. Feeding black holes, glitching neutron stars, and highly magnetized neutron stars called magnetars are all suspected. Or on the other hand, it could simply be that all fast radio bursts are repeaters, with some just a lot more active than others. Currently, confirmed fast radio bursts number in the hundreds, and scientists are assembling mounting evidence that they are triggered by magnetars. And that's where this latest research comes in. It's found that fast radio bursts are more likely to occur in massive star-forming galaxies rather than low-mass ones. And this finding has in turn led to new ideas about how the magnetars themselves are being created. Specifically, the new work suggests that these exotic dead stars, whose magnetic fields are 100 trillion times stronger than the Earth's, often form when two stars merge and then explode as a supernova. Previously, it was unclear whether magnetars were formed from the explosion of two merged stars or whether they might form when a single star explodes. The study's lead author, Kriti Sharma from Caltech, says the immense power output of magnetars makes them some of the most fascinating and extreme objects in the universe. But very little is known about what causes their formation upon the death of massive stars. And that's where this new work comes in to try and help answer that question. Sharma and colleagues use Caltech's Deep Synoptic Array 110 in the Owens Valley Radio Observatory near Bishop, California. That array's already detected and localized some 70 fast radio bursts, pinning them down to a specific galaxy of origin. Although fast radio bursts are now known to occur in galaxies that are actively forming stars, Sharma and colleagues found that they tend to occur more often in massive star-forming galaxies rather than low-mass star-forming ones. And that's important, because massive galaxies tend to be more metal-rich. That's because the metals in our universe, that is, the elements manufactured by stars, take time to build up over the course of cosmic history. Now, of course, when astronomers speak of metals, they're speaking of all elements on the periodic table other than hydrogen and helium, the elements created in the Big Bang itself. The fact that fast radio bursts are more common in these metal-rich galaxies implies that their source magnetars are also more common in these types of galaxies. And the simple fact is, stars that are rich in metals tend to grow larger than other stars. Over time, as galaxies grow, successive generations of stars enrich those galaxies with more and more metals as those stars evolve and die. Also, massive stars that explode in supernovae and can become magnetars are more commonly found in pairs. In fact, some 84% of all known massive stars are in binary systems. So, when one star in a binary system is puffed up due to extra metal content, the excess material gets drawn over to the binary partner, which facilitates the ultimate merger of the two stars. These now merged stars would therefore have a far greater combined magnetic field than that of a single star. And a star with more metal content expands and drives more mass transfer, culminating in a merger and thus forming an even more massive star with a total magnetic field greater than what the individual star would have had. It's nice when the pieces all fit together. This is SpaceTime. Still to come, Voyager 1 about to reach a distance of 1 light day from Earth, and a vital military satellite defense system axed by the Albanese government. All that and more still to come on SpaceTime. NASA's Voyager 1 spacecraft is about to become the first man-made object to travel more than a light day's distance from Earth. Now, to put that in perspective, a light day is a distance of 26 billion kilometres. Now, the historic achievement won't happen for a while yet. It'll be January 2027, but it's worth mentioning it. Voyager 1, together with its twin Voyager 2 spacecraft, are continuing their journey through unexplored interstellar space. And it's been a drama-filled mission, with tensions again set soaring recently when Voyager 1 suddenly lost contact with mission managers. Scientists were concerned that the unexpected loss signal might have meant the end of the historic 47-year-long interstellar mission. Turns out the loss of contact was triggered by a glitch in Voyager's fault protection system that caused its primary radio transmitter to suddenly switch off. Eventually, engineers were able to re-establish contact and identify the source of the problem. Now, this system usually autonomously manages onboard functions, reducing power use by deactivating non-essential equipment in order to safeguard the spacecraft's core operations. The incident unfolded when the flight team, based at NASA's Jet Propulsion Laboratory in Pasadena, California, commanded Voyager 1 to power on a heater on October the 16th. Now, although the spacecraft seemed to have enough power, the command unexpectedly triggered a fault protection system. And on October the 18th, NASA's Deep Space Communications Network was no longer able to detect its signal. Initially, engineers hypothesized the fault protection system had reduced the data transmission rate on the X-band radio transmitter, requiring less power but complicating signal detection. Eventually, they were able to detect a weak signal coming from the spacecraft, indicating that Voyager 1 remained operational and was in a stable condition. However, the following day, October 19th, communications appeared to cease entirely, leading the team to suspect that Voyager's fault protection system activated again, switching from the primary X-band transmitter to a much weaker S-band transmitter. Now, this S-band transmitter has not been used since 1981. It emits a weaker signal and therefore presents a far greater challenge for detection over Voyager 1's nearly 25,879,000,000 kilometre distance. Glenn Nagel from NASA's Deep Space Communications Network complex near Canberra says engineers managed to pick up the S-band signal and confirm that Voyager 1 remains operational, although full functionality has not yet been restored.
Yes, just in recent times, a standard command set sent to the spacecraft commanded it to turn one of its onboard heaters on, and that seems to have tripped a fault inside the computer on the Voyager spacecraft, and it did something that wasn't expected. Normally the spacecraft transmits to us on its X-band transmitter, which is a good strong frequency that we can get back data from the spacecraft and understand about the health of the spacecraft. But this fault turned off the X-band and turned on the S-band communication. Now, the S-band transmitter hasn't been operated in over 30 years, but this S-band switched on and worked. But the problem with S-band, it's a much wider band, a much wider frequency, and much lower signal coming back to the Earth. So unfortunately, the spacecraft, while we could hear it barely above the background noise of the rest of the universe, we could not get science data from it. But what we discovered is the spacecraft was still commandable, and that was really great news. We could uplink commands to the spacecraft. We had to wait for nearly 46 hours at round-trip time at the speed of light to get the signal to Voyager 1 and back again, and be able to determine that the spacecraft was responding to the commands that we gave it, to some little offsets in the frequency that it was transmitting at. So that was good news. So we're in lock with the spacecraft. In fact, as we're speaking right now, we're actually talking with Voyager 1 through our big dish here in Canberra. And so the spacecraft seems to be good, in good health. And now it's just up to the science team to try to figure out what was the fault, how can they rectify it, how can we switch back to the X-band transmitter and get back in full science mode with Voyager.
Well, of course, the two Voyager twins are getting on in years, aren't we all? And there have been a couple of incidents of late.
Yeah, so they've been both out there for over 47 years now. And just like a lot of us, we might get a little bit forgetful from time to time, have a few aches and pains as we wake up in the morning. Last year, Voyager 2, we lost contact with it for a few weeks when an incorrect command set to the spacecraft recalibrated its antenna to actually point away from the Earth. And again, it was sort of Canberra to the rescue. We're transmitting at high power to the spacecraft to relock in on its computers, even though the antenna was pointed away from us, and to be able to get it back to science again. And it's been quite in good health over the last year and a half or so. But Voyager 1 earlier this year also had a problem on board. Its onboard computer, which we're talking about computers that were built in the 1970s, some very, very basic chips on that spacecraft. And when I talk about a chip, not like the little tiny ones you might have in your car fob, these are ones that are 10,000 times less powerful than what's in your car fob to open the car door. And these, one of the little chips out of a set of 8 must have been hit by a cosmic ray strike. And that flipped a bit on that and made that particular chip unusable. And so it took a while to determine what was the problem. The spacecraft was sending back gibberish to us, basically. Spacecraft is talking in binary code, ones and zeros. And we're either just getting ones or just getting zeros. And that doesn't tell us anything about the spacecraft. It is just nonsense. But some great engineers within the science team and within the Deep Space Network that we're a part of actually noticed that there was some information there, buried quite deep into the data. And that helped us understand what the problem with the spacecraft was, to identify the problem with the chip on board, and then to write a program which we were then able to uplink through our antennas and transmit to the spacecraft to ensure that it could then go, don't look at that chip anymore. Let's distribute the program across the other chips, which we still know are working. And as soon as that was done, we waited an anxious 46 hours for the transmission time there and back, and we received the data, and Voyager 1 was back in full communication. So this is just another one. This current pause is just another one of a series of issues with an aging spacecraft. But you've got to remember, nobody ever expected Voyager to last this long. They were a 12-year mission. Go and explore the giant planets of our solar system. They finished that journey in 1989, but they've kept going. They've now left behind the solar system. They're both in interstellar space. They're still telling us new and unique things about a region of space that nobody ever thought we'd be having a spacecraft operate and to explore that region so soon. So they've got a remarkable legacy behind them. They have a remarkable journey ahead of them.
Scientists are still using the data they gathered back in the 1980s to carry out new studies of bodies within the solar system. Some Voyager 2 data just the other day was used to confirm that the Uranian moon, if that's the correct term, Miranda, possibly has a liquid water ocean under its surface.
Yeah, it is remarkable. We're still mining that data, both for scientists all over the world and even some amateurs using some of the available Voyager data to actually make new discoveries, even find a once thought of moon that was sort of lost out at Neptune and rediscover that in some of the images just through amateurs working on the data. So it's amazing that after 47 years, these two spacecraft are still telling us new things about our own solar system and are now telling us about the rest of the universe.
That's Glenn Nagel from NASA's Deep Space Communications Network near Canberra. The incident is the latest example of the mission's complex engineering demands, especially as the twin Voyager spacecraft, which were launched back in 1977, are edging ever closer to the half-century mark. Voyager 1 entered interstellar space, that's the region of the galaxy beyond the heliosphere, the bubble created by the solar wind and magnetic field emanating from the Sun, back in 2012 when it was some 123 astronomical units from the Sun. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. Voyager 2 followed its twin into interstellar space in 2018, although travelling in a different direction. In the decades following their launch, on August the 20th and September the 5th, 1977 respectively, the Voyager twins have undertaken a grand tour of the outer solar system, studying Jupiter, Saturn, Uranus and Neptune. Now, if nothing else goes wrong, the Voyager probes could continue to operate using their existing power reserves until the late 2020s. But as time goes by, continued operations are becoming more and more challenging, with mission power diminishing by 4 watts every year, and the two spacecraft will continue to cool down as this power decreases. This is SpaceTime. Still to come, the Australian government acts as a crucial $7 billion satellite defence project, and later in the science report, it turns out people using private jets generate 500 times more carbon dioxide in a year than the average person. All that and more still to come on SpaceTime. The Australian government has just axed a crucial $7 billion satellite defence project. The move is a significant blow to Australia's defence capabilities, and it comes at a time of growing regional tensions between China and Taiwan, China and India, and Beijing's ever-expanding interests in controlling the South China Sea. The ambitious JP-9102 military satellite communication system was awarded just 18 months ago to US defence contractor Lockheed Martin. Its sudden cancellation marks a dramatic reversal for what was a key project designed to make Australia's military communications safer at a time when the cyber attack and electronic warfare landscape has been dramatically evolving. As well as launching numerous large military-grade satellites, the program would have also included satellite communication ground stations and a central mission control system. The planned satellite network would have provided advanced encryption and anti-jamming capabilities, creating what experts call an uncrackable data network across the Australian Defence Force. It would have provided secure communications for military aircraft, naval vessels and ground forces over the vast Indo-Pacific region. Without it, Australia's military lacks the comprehensive coverage and secure communications network that JP-9102 would have delivered. The decision comes at a time when Australia's Foreign Minister Penny Wong has given more than $32.2 million of taxpayer money to groups like UNRWA, the controversial United Nations organisation with close ties to Hamas and other Palestinian terrorist organisations. The news of the satellite contract cancellation also comes in the wake of a promised cut of $16 billion by the Albanese government in future HEX debt repayments by university students if it wins the next federal election, slated for sometime around May next year. China, Iran, North Korea and Russia are all widely recognised as having advanced capabilities to jam satellite signals, intercept communications, undertake cyber warfare and take control of satellite systems. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. The next time politicians and celebrities bleat out about their green credentials, it might be worth reminding them of a new study which has found that people using private jets to get themselves around the globe generate some 500 times more carbon dioxide every year than the average person. The findings, reported in the journal Communications, Earth and Environment, also showed that the annual carbon dioxide emissions from private planes has increased by 46% between 2019 and 2023. The study also found significant emission peaks around certain international events, including the 2022 FIFA World Cup, Cannes Film Festival, and ironically, the COP28 United Nations Climate Challenge Conference. The data shows Australia currently has 317 private jets, which accounts for 1.2% of the global total, but it ranks 6th highest globally for the number of planes per 100,000 residents. A new study has identified 22 pesticides consistently linked to the incidence of prostate cancer. The findings, reported in the journal Cancer, assess links between 295 different pesticides and prostate cancer using a lag period between exposure and cancer incidence of 10 to 18 years. The time lag was needed because most prostate cancers grow slowly. The years 1997 to 2001 were assessed for pesticide use, and the years 2011 to 2015 for prostate cancer outcomes. Similarly, 2002 to 2006 were assessed for pesticide use, and 2016 to 2020 for outcomes. Among the 22 pesticides showing consistent direct links with prostate cancer incidence across both analyses were 3 that had previously been linked to prostate cancer, including 2,4-D, which had been used for weed control in Australia since the 1960s. The other 19 pesticides had not been linked to prostate cancer before. and included 10 herbicides, several fungicides and insecticides, and 1 soil fumigant. 4 pesticides linked to prostate cancer incidence were also linked with an increased risk of death from prostate cancer. 3 herbicides, trifluoralin, which is approved for use in Australia, chlorancyl methanol, which is not approved in Australia, and diflufenzaprine, for which there's no Australian information, and also 1 insecticide, thiamethoxam, which is also approved in Australia. A new study has found that humans aren't the only species that deliberately consume alcohol. The findings, reported in the journal Trends in Ecology and Evolution, looked at growing evidence of how commonly ethanol naturally occurs in fruits and nectar that are commonly food for wild animals. The researchers say most animals that eat sugary fruits are likely to be exposed to at least some ethanol. And while most naturally fermented fruits only reach about 1 to 2%, concentrations as high as 10.2% have been found. The authors admit there's not much we know about why animals might choose to consume ethanol. That's because being drunk's generally a bad idea when you're living in the wild. However, it's possible that while humans like the effects of alcohol but not the calories, other animals may be risking the effects specifically to consume the calories. A new systematic review covering thousands of studies has confirmed yet again that there's no scientific evidence that cell phones can cause brain cancer. This latest review was commissioned by the World Health Organization and published in the journal Environment International. It's the most comprehensive review so far and included more than 5,000 studies, of which 63, published between 1994 and 2022, were included in the final analysis. Tim Mendham from Australian Skeptics says, while there are a few isolated studies that have raised concerns, a more complete examination of the data has negated those results.
You sort of wonder how much proof do you need, but obviously in certain circumstances people just don't believe the proof, so you've got to say it again and again and again. People looked at individual studies and done their meta-studies of thousands in some cases of other studies, and looking at those that are good and those that are bad studies, etc., and they come to the conclusion, no, there ain't no problem. It's not going to cause brain cancer. You might spend too much time on the phone, but that's a different issue. But yeah, this theory that it was causing brain cancer, the radiation from mobile phones you hold to your ear when you're listening to them is going to sort of give you cancer is not true. Over hundreds and thousands of studies, over millions of people, over a long time that mobile phones have been available, there is no evidence that it's causing brain cancer.
There's just been no correlation between the increase in cell phone usage. Brain cancer rates have not increased.
Brain cancer rates have not increased, but the usage of the technology has dramatically increased.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.